This is Miss Moriarty, and I'm here to discuss with us topic 9.3 as well as 9.4. Both of these topics, we're going to talk about what is the greenhouse effect and what are the impacts of increasing those greenhouse gases. So, we learned today from the video in our activity that the six principal greenhouse gases we need to be familiar with are carbon dioxide, CO2, methane, CH4, water vapor, H2O, nitrous oxide, which is N2O, and chlorofluorocarbons. Now, water vapor is considered a greenhouse gas, but be careful. It doesn't actually significantly contribute to global climate change because it has a short residence time in the atmosphere, meaning that it doesn't spend that much time in the atmosphere compared to some of the other gases like CO2, methane, nitrous oxide, or chlorofluorocarbons. Now, overall, what is the greenhouse effect? Well, it is the result of the surface temperature warming, making it necessary for life to exist on Earth. Now, in looking at those principal greenhouse gases, where might some of their sources stem from? Well, CO2, which we've talked a lot about this year, tends to come from fossil fuel combustion. It can come from decomposition in the soil or maybe in a landfill. It can also be emitted in a forest ecosystem that has been recently deforested. Methane or CH4 can stem from natural gas extraction, right? If someone is using fractional distillation to obtain any natural gas, some of that methane could wind up leaking out. It can also stem from animal agriculture. When we see lots of livestock in a very concentrated area, in a CAFO, for example, that has the ability to produce a lot of methane. We can also see it come from actually the permafrost found in the Arctic. When the permafrost melts, it can actually release a lot of methane as a result. Nitrous oxide, or N2O. This can actually come from the denitrification of nitrate found in our soils, especially when we use synthetic fertilizers or even overwater an agricultural field. CFCs, HCFCs, or HFCs, any of those combination of compounds, remember we know are refrigerants found in potential aerosol products. Those are also considered to be greenhouse gases. And then water vapor, H2O, can come from evaporation or transpiration from plants. Now, in looking at our six principal greenhouse gases, we said although water vapor is considered a greenhouse gas, it's not really one in which we worry about too much. It has a very short residence time in the atmosphere and doesn't have that great of a global warming potential. Now, we tend to use carbon dioxide as our reference point in trying to compare our different greenhouse gases, since CO2 has a global warming potential of 1. Now you can see, looking at the table here, our chlorofluorocarbons have a much, much greater global warming potential, and they also pose great harm because they can remain in the atmosphere for very long periods of time. So you can see some of those other principal greenhouse gases are far more damaging than simply just CO2. At this diagram, guys, this is showing us or outlining for us the principles of the greenhouse effect. So in our activity today, we attempted to simulate what we see in this picture. So here, our yellow puffballs should have simulated photons or UV radiation entering through Earth's atmosphere. We know that depending upon the color or albedo of the surface of Earth, some of that radiation is going to be absorbed and naturally warm that area, versus some is going to actually be reflected by Earth and back into the atmosphere, back into then space. Now, some of the infrared radiation that winds up passing through the atmosphere gets reabsorbed or re-emitted in all directions by our greenhouse gases, kind of creating that warming blanket effect. And so this is what's going to continue to naturally warm Earth's surface and the lower part of the atmosphere. So it's important to note UV rays enter From the sun to Earth's surface, infrared radiation is then absorbed by greenhouse gases and re-emitted in all directions, naturally warming Earth. Okay. Now, not all incoming solar radiation actually winds up even reaching Earth's surface to begin with. Lots of it's actually reflected back into space by the clouds or even the atmosphere. Remember, we said, though, depending upon the albedo of Earth's surface, we're going to see some maybe absorb more or less infrared radiation. So that if the surface is darker, which has lower albedo, it absorbs more sunlight and releases infrared radiation where greenhouse gases are going to trap. Versus the lighter or high albedo surface is going to reflect more sunlight back into space, or maybe even have more clouds and greenhouse gases that may absorb it. Now, in topic 9.4, this is now what are the consequences of potentially increasing greenhouse gases, right? All of the anthropogenic effects that may emit more greenhouse gases into the atmosphere, and what are the causes of that. So we know that that's going to lead to many environmental issues, and those environmental issues can actually wind up changing then population dynamics and movement. Some very common anthropogenic increases in greenhouse gases are deforestation, agriculture, right? The use of mechanization for monocultures, the establishment of CAFOs or concentrated animal feeding organizations, landfill constructions tend to release lots of greenhouse gases, the use of fossil fuels for industry, electricity, transportation, any numbers of those are all examples of how an anthropogenic source of greenhouse gas emissions. Now, as a result of increase in greenhouse gases, which means we enhance the greenhouse effect, we're going to see over time rising sea levels. Now, this is in part due to two reasons. One being called thermal expansion. So as water molecules move slightly apart when they're heated, all of those water molecules in the ocean are going to move apart and expand, causing the sea levels to then rise, as you can see in the diagram there. We can also see that at the ice caps, we're going to see lots of melting of sea ice and glaciers as we increase greenhouse gases, making our climate warmer, only allowing more and more water to flow into the ocean, expanding more, leading to even more sea levels rising. Another consequence of increasing greenhouse gases will be disease vectors. Remember back in Unit 8, we talked about disease vectors are usually things like mosquitoes or rodents, and a lot of those organisms tend to thrive in very warm or moist environments. And with warmer temperatures, we're going to see that those disease vectors are going to be living for longer periods of time, being able to spread across parts of the world that they may not have been previously. And so this poses a tremendous risk to human populations, especially if they've never faced diseases such as malaria, Zika, West Nile, and so on. All right, everyone, that is it for our video on 9.3 and 9.4. Be ready to continue working on our greenhouse effect simulation tomorrow and talking about our notes video.